Hi everyone, it's Par again. This video is going to focus on data representation, specifically sound. This is a paper 2 topic. This is one of the most common areas where people struggle in data rep. Binary conversion, most people are happy with. Hex, slightly more difficult, but people learn how to do it. Images, people are okay, but people struggle with sound. So what I'm going to do is just go over, recap the theory behind it, and then look at some past exam questions. Simple as that. Okay. As per usual, feel free to pause the video, make notes or whatever. But when it comes to the questions, pause the video, have a go yourself, and then I'm going to go through the answer. All right. So we start off with thinking, well, what is sound? Well, sound is basically vibrations. So when a speaker actually makes a sound, what happens is this cone, it just moves forwards and backwards really, really quickly, and it compresses the air, okay, to make these sound waves, okay, and these travel throughout the air, and then they hit our ear, and our eardrum receives those vibrations, those waves, and depending on how fast it moves, how compressed the waves are, it makes a different sound. Okay, and so here's an example of a typical sound wave. Now, if you think about it, if you ever go to the sea, or if you go and see, I don't know, go to, I don't know, river or whatever, any sort of body of water, and you see a wave. Now, a wave always moves. It never kind of stops where it is and you can just sit sat there. It's constantly moving. And this means it is analog. Okay, so sound is analog. In other words, it's constantly moving. Okay. Now, computers don't like things which move. They want to measure it. They have to store things as a number, as a binary number. Okay. So some way we have to convert our analog sound wave into something which it can remember, which is digital, often called discrete. Okay. That's spelt wrong. Ignore the A. So we have to somehow get our constantly moving sound wave, okay, and convert it into something which the computer can understand. When it comes to our ear, our brain does that. Our brain takes that sound wave and our eardrum kind of turns that into electrical pulses, which goes to our brain and we can understand it. Okay, so what we need to do is get the computer to do something similar. Okay, so what happens is we take our annual signal and it goes through something called an ADC. This is something called an analog to digital converter. Okay. So what that will do, that will convert your sound, your analog sound, your sound wave. It's going to do something to it and convert it into a digital signal, what's called discrete. Okay. So how does it work? So let's say we've got our sound wave. We need to actually convert this into digital. So what we have to do is we have to basically take measurements of our sound wave and convert that into a binary number for the computer to remember. This is what's called sampling. Is basically measuring the sound wave. Okay. Now, what exactly are we measuring? We are going to be measuring the height of the sound wave. Okay. This is what's called the amplitude. So sampling, okay, is the measurement of the amplitude of a sound wave at regular intervals. Okay, so there's our sound wave, and what we need to do, we've got to basically measure how high this sound wave is and store each measurement as a number for the computer to remember. Okay, so let's do it very, very simply. Let's say across, this is time. Okay, and obviously up here is the height of the amplitude. Okay, so let's keep it nice and simple. Let's say this is 1 second, and then we have 2 seconds. Okay, and let's say let's work on a Dino scale between 0 and 10. Okay, so let's say we measured, let's just say once every half a second. Okay, so at the beginning here, let's say, so every half a second, at this point we'll measure it here, and it is 0. Okay, at 1 second it's 0. Oops, go away. Okay, next one is 0. Right, oops, and 0. Sorry. So if we measured every half a second, that's no good, because every half a second, if we measured every half a second, we wouldn't hear anything. Okay. Now, if we measured every quarter of a second, okay, so we're going to measure here, oh, it's 10. Then we measure here, it's 10. We measure here, 10, 10, 10. So here, we're measuring every quarter of a second. Our sampling, we're sampling once every quarter second. So our actual digital sound wave would look like this. It will go from 10 and then drops down to 0, goes across to 10, excuse my accuracy, down and across and up and out and up and out and up. You get the idea. Excuse my terrible drawing. So there, the red is the digital sound wave. Okay, now let's try and test my voice now. So let's say I'm going to follow the blue analog sound wave. It might go like that. Okay, now when you heard my voice then, crap as it was, you heard the bits in between the highest and Now the digital sound wave wouldn't do that. It would go it's kind of like a police car, isn't it? So you can see that our digital sound wave, it's okay, but it doesn't represent our analog sound wave that accurately. Now, why do you think that is? Okay, there's a couple. Okay, well, the key thing is basically I'm not sampling often enough. Okay, I'm only sampling every quarter of a second. Now, if I measured again every eighth of a second, we could then have a bit more accuracy. Okay, but essentially, sampling is just the measurement of the amplitude of a sound wave at regular intervals. Okay, we'll go into a bit more detail in a bit. So, as we've just seen, how often we sample our sound wave has an impact on the quality. All right, so the sampling rate is basically how often we sample the speed. We could sample once every second, or once every half a second, or once every eighth of a second, or so on and so on and so on. Okay, this is what's called the sample rate, sometimes called the frequency. So the sample rate is how often or frequent you record the amplitude of the sound wave. The more often you record the sample, the smoother the playback will sound. So what we've got here is a sound wave, the grey wave. Okay, and you can see here they've got a sampling rate of what's called 3 Hertz. In other words, it samples 3 times every single second. There's 1 second, 2 seconds, 3 seconds. So every second it measures 3 times. Okay, so there's our first measurement, one there, then our seconds there, and our thirds there. Okay, so it's okay. However, if you look, if you go from this first bit from the start to our first measurement, according to this, it stays the same, but the actual sound wave, it goes quite low. All of that is missed out, okay, because it's not measured because it's in between our sample points. Okay, then it says here, apparently between there, it goes across then down to here. Well, what about this bit here? We're missing out on that change. It goes okay. Here it goes down, up, and then up and then down and up, that's completely stays the same there. Okay, because we're only sampling once every 3 seconds. Now, if we increase our sampling rate, also called the frequency, you can see here. So here it's been doubled to a 6 hertz, so 6 times per second. Now, by doing that, look at this orange waveform. Okay, it is a bit more accurate compared to the original. Yeah, it's not perfect, it misses bits out, but it's a lot more accurate than the 3 hertz sample rate. Okay, so your sample rate is basically the number of samples which are done per second. It is measured in hertz. If you did 1 per second, it'd be 1 hertz. Okay, in these examples, they're not realistic, okay, but they're good to see. In realistic terms, you would a CD quality is 44 kilohertz. So every second, you would have 44,000 samples. So in that space there, okay, rather than having 6 sample points, you'd have 44,000. And that way, it's a lot more accurate to the original sound wave, the sound file. And so it is a lot smoother. Okay, that is the sampling rate. Now, another way we can increase our quality is to change what's called the bit depth, often called the resolution. Okay, the bit depth, and this is basically how accurate you can actually record a sound wave. Okay, I'm going to go back to this one here, get rid of my crap drawings, and let's do it very basic. Let's get rid of all this. Blah 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 blah. Okay, we'll keep our 1 second and 2 seconds. Blah blah blah. Okay, so let's speak in binary, and let's say we are using a bit depth of 1 bit. Okay, 1 bit. If you remember, a bit is a 0 or a 1. So basically, that is how many levels we can measure this sound wave. So basically, that's our height. Oops. Okay, and we can only measure it between 0 and 1. Those are our sampling points. And let's say we can measure our sampling rates, 4 times a second. So our first measurement is going to be here. That's going to be, the computer's going to store that as 1. Then our next point is going to be there. It's going to be 0. Next one's going to be there. 1, 0, 1, 0, 1, 0, 1. That's fine. Well, let's say we measured in between. We increased our sampling rate. Okay, and let's say we measured 8 times per second. Now, we'll start off here. Now, the problem is there's no way to measure that because we've only got 0 and 1. So we'd have to actually basically measure this as a 0 here. Okay, what about here? Okay, maybe that's a 1. So then what's going to happen is, okay, it's not measuring it accurate enough. We can't measure it here because there's nowhere on our scale to do it because we're only using 1 bit. So what you'd have to do then is increase our resolution, okay? In other words, our bit depth, and introduce another bit. So what we could do is do 2 bits. And by having 2 bits, you could have 0, 0, 0, 1, 1, 0, or 1, 1. You could have 4 places to measure. Let's see a better example. So here's an example of a sound wave with a 2-bit depth. In other words, it uses 2 bits. So this would be 0, 0, that would be 0, 1, 1, 0, 1, 1, using 2 1s and 0s. So we've got 4 levels of which we can measure. Okay, so the issue is here though. If you look here at this point here when we're sampling, the actual wave is there, which should, okay, it should be there on the scale. But the problem is there's not a measurement, so it rounds it up to 2. So that's why it goes there. Okay, now down here, this actually goes quite low, and it should be measuring it about there, but there's no point there because we haven't got a resolution high enough. In other words, we haven't got the bit depth high enough, so it rounds it up to 1. So you can see here it's not quite as accurate. Okay, so for example here, this one here, it should be measuring it to about there, but it rounds it up because there's nowhere on the scale which can measure it that accurate. It has to fall between one of these measurements. Okay, so the problem with a low bit depth, it doesn't, the quality isn't as good because it's not as close as accurate to the original. Okay, so the bit depth represents how different gradations of amplitude can be represented. In other words, how many different levels can be represented. So if we increase it to a 4-bit depth using 4 bits, you can see here we have a lot more points at which we can measure. Okay, so let's go back to this one here, this third sample here. On the 2-bit depth, it's measured as 1. On this one, you can see here, it's actually measured as 3, which is a lot more accurate. Okay, so because this is a 4-bit depth, the actual binary numbers would be anything from 0, 0, 0, 0, all up to 1, 1, 1, 1. Okay, so because 1, 1, 1 is 15 in binary, which is actually altogether there's 16 different points. Okay, 0 up to 15. Okay, so your bit depth is measured in bits. Okay, we looked at 2-bit, 4 bits. In real life, CDs uses 16 bits, and by using 16 ones and zeros, okay, that will give you up to 65,000 points of measurement, which makes it a lot more accurate and makes it sound realistic. Okay, let's skip ahead and let's do a few exam questions. So if you want to just pause and have a go at this question while I've sip of my coffee, and then I will go to the answer. As I said, I'm sipping coffee, and somebody called Coffee or Kofi. Lol. Right, I'm going to call him Kofi, or him or her, sorry. Kofi uses his computer to record an audio file of himself playing his guitar. Outline what happens when the computer converts his music into a file. Okay, now our command word here, if you didn't know already, is outline. Okay, and that's quite broad. It's worth 2 marks. Okay, so basically this is showing your knowledge and understanding. Okay, so what happened when the computer converts the music into a file? So when it gets the sound from his guitar, what happens to it? Okay, well, this is all about sampling. So what can we say here? What happens to the computer? Okay, so the sound from the guitar, okay, and that's actually the sound wave is sampled. The amplitude, because we're explaining what sampling is, of the sound wave is measured at regular intervals. It's not just once. Okay. Okay. These measurements are then stored as binary on the computer. Okay. You could actually, it could be a lot simpler. That you could just say the height of the wave is measured and then turned into binary. You could just say that. Okay. I always like to put a bit more detail. Okay. So converting the music from analog to digital, sampling, measuring the amplitude of the sound wave, and stored as binary. Basically, the way the marks will be allocated here, you probably get, let's use the green pen. Okay, we've got the mark for saying 1 mark there, measured at regular intervals. Another mark for saying stored as binary. That's the key thing about it being digital. It's got to be stored as a binary number. Okay, let's move on to the next one. All right, so this is still on the same thing about coffee. Here it says coffee increases the sample rate. Okay, his computer. Kofi increases the sample rate his computer is using to record his guitar. So remember the sample rate. Okay, and this is how often. Rate is a speed. Okay, so it's how often it is sampled. Okay, explain. So explain is our key word here, our command word. Oh, what am I doing that for? Should have been my highlight. Anyway, you get the idea. Explain 2 effects this will have on Kofi's recording. Now it's worth 4 marks. So with your explain, you have to make your point, and then because. Okay, so we've got to explain the effect and then because. All right then. So what's the effect of increasing the sampling rate? So we can say what one effect would be file size would increase. You get a mark for that. We don't get the second mark yet until we've explained why. We have to explain why. Because there are more samples to store. 2 marks. Okay, so the file size would increase. There's your 1 mark. Because there are more samples to store. 2 marks. Explain. Okay, what's the next effect? Quality of the recording would improve. Okay, there's your 1 mark. Because sound wave is more accurate to the original. Because you're making more samples, okay, that means it's going to be a lot more accurate. All right, there you go, 2 marks. Quality would improve because the sound wave is more accurate to the original. 4 marks. Okay, I'm going to have a quick sip of my coffee. If you want to copy that down and just pause it, that's fine. Okay, I'm going to go through a few more questions. These are basically going to be very similar questions we've done already, so feel free if you want to stop the video and you're quite comfortable with it, that's fine. But I'm just going to carry on if you want to see a few more examples. Okay, so when recording a sound file on a computer, the sound needs to be sampled. Okay, describe how sampling is used when storing sound. Well, this is basically exactly the same as that first question. Okay, what happens when a computer converts music into files? Just this question doesn't have the word sampling. Okay, so describe how sampling is used. Well, basically describe what sampling is. So we can just say once again, the amplitude of the sound wave, okay, is measured at regular intervals. Okay, you probably get 1 mark for that. Okay, so these measurements then stored as binary. Okay, there we go. 2 possible marks. There we go. Pause it, have a sip of coffee, then on to the next question. Right, 3 marks. Explain the effect of the sampling interval. Okay, so I'm just going to do my, no, I don't want that. Use my highlighter. So there's my command word. Explain. Don't forget, make your point and then because. Explain the effect of the sampling interval on the size and quality of the sound file recorded. Okay. I don't want that. Oh, don't want to do that. Let's go back to my pen. There we go. So the key thing which we haven't seen before is where's my pen gone? Where's it gone? No. Oh, what is going on here? I want red, please. There we go. So it's this word here, sampling interval. Explain the effect of the sampling interval. What is an interval? Well, interval is like a break or a gap. Okay, in this context, it's basically the sampling rate. So what's the effect? Explain the effect of the sampling rate on the size and quality of the sound file recordings. Basically, if you change the sampling rate, either increase it or decrease it, it's up to you. What is the impact on the size and quality of the sound recorded? Now, what a lot of people forget to do, they don't read it properly and they don't include both of these. It's worth 3 marks. So what I suggest you do, you explain the impact of increasing the sampling rate and see what happens to the file size and why. What happens to the quality and why. Okay. So what we can say here is, if the sampling rate increases, so in brackets, the interval between samples is smaller. That's basically what you're saying. You don't have to put that in brackets. So in other words, the interval, the time between your samples is smaller, so you're increasing the rate at which you're sampling. Okay. If the sampling rate increases, in other words, okay, more measurements are taken, which would increase file size, because you're actually taking more measurements. There's more data being taken. Okay. Sound file quality would increase, would improve. Yeah, would increase. Well, it actually would be more accurate to the original. Okay, would be more accurate to the original. Actually, sorry, the sound. Let's go with that. Sound file would be more accurate to the original, and therefore better quality. Basically, increase your rate, more files, increase in file size, but more accurate to the original, so better quality. Okay. Only one more, I think. No, 2 more. Nice and easy. Well, this is exactly the same question we had before. Alex needs to create an audio recording of himself playing his guitar. A lot of people playing guitars. Explain how sampling is used to make the recording. Okay. Well, this is. Have we done this already? Well, it's the same question. It's exact. I'm not going to write this down again, but it's exactly the same as that. So, describe how sampling is used when storing sound. 2 marks. Explain how sampling is used to make the recording. So this is worth 3 marks. So it's exactly the same. So blah blah blah. The amplitude of the sound wave is measured at regular intervals These are then stored as binary values. How can we get an extra mark, do you think? Okay, well, in the actual mark scheme, it says this. You could say the samples form an, good word, approximated sound wave. Okay, so if you think about it, our original goes like that, and then our digital one probably not like that. It'll be like kind of like, imagine these are all different measurements. Up, down, up, down. It's an approximated. It's never going to be exactly the same. That's impossible. Okay, it's an approximated, a good representation of it. Okay, so measure wave interval, 1 mark, stored as binary, 2 marks. The samples form an approximated sound wave, 3 marks. Okay, last question. Okay, nice and simple. Okay, state the effects of increasing the sampling rate. Now this one, this keyword here, the command word, all right, highlighter, let's go for yellow, is state, and it's worth 2 marks. So in this case, you haven't got to remember explain, you have to state something and explain why. With state, you don't. You just say what is the effect of increasing sampling rate. So two different statements. So state the effect. Okay. So file size would increase. Okay. And we could say quality would improve. Okay, it doesn't ask you to explain why. Okay, just state the effects of increasing the sample rate. If you're not too, if you know, by all means, add on to that. Okay, file size would increase because more samples are being taken per second. Quality would improve because it's going to be more accurate to the original. Okay, by all means, put that in. All right, but normally state, that's what you have to put in then. Okay, I hope that's been useful to you. Audio questions, people always stumble upon them. There's a lot of keywords. You need to understand what they mean and don't get them mixed up. That's the key thing. So keywords, amplitude, sample, rate, also known as frequency. Okay, and we have bit depth, sometimes known as resolution. Okay, right, hope that's been useful. Any feedback on the videos, let me know and I'll get more out to help you with your exam. All right, thanks very much. Take care. Bye.